Okay, we're on number 3 again, shell method. They got a region, under the curve, over the interval, about the line x equals 0. All right, what do? I need to visualize it. There's no doubt about that. So let me put that down for you. And again, don't lose sight of what you're reading. Like if you think you're memorizing what you've read, you shouldn't be memorizing what you've read. You look back over it. And what do I got? I got a curve, y equals 1 over the root of x squared plus 1. It's not an easy graph, but I'll be honest with you, I'm not looking for perfection. I'm looking for something that looks remotely like that. So 0 to 2, and get a line x equals 0. Again, this is the interval, x on that interval over there. So I'm going to just, talk about one step at a time and think about it. Like if I put 0 into that, what would I get? I get 1 into this, by the way. Let me go to 2, see what you get. Well, that would give me 4. 4 plus 1 is 5. So it's 1 over the root of 5. So it definitely got smaller. I'm going to say it's over here somewhere. All right? And I'm going to say it sort of looks like this over here. All right? Sort of. Then what do I got? Well, I got a line, x equals 0. Looks like this over here. And I'll stop it there. I see the region now. This is the region. All right, I got to go back and read it to you. It says, use the shell method to compute the volume of the solid obtained by rotating the region underneath this graph. I see that. Over the interval, about the line x equals 0. I'm sorry. That's the y-axis. I'm rotating like this. Well, I'm getting more experience with this. I still use my rectangle, though. Differentials dx. Where are we going from 0 to 2? 2 pi r. The r here is going to be x. And now I got to get the height of that rectangle, right? And what's that going to be? Well, that's not so bad. It's just upper minus lower. This is the upper curve. The lower curve is just simply y equals 0. So I get this over here. Now I realize for a lot of students are saying, I can't do that. Yes, you can. Right, so let's talk about that. Now, granted, you're in a place now where you've seen a lot of different types of. Now, I shouldn't say a lot. You've seen some integration techniques. One thing I'm going to point out is just a u substitution, and I'm going to say u equals x squared plus 1. That means du would be 2x dx, and I'm going to use that substitution now to change this integral. So I want to look around, and I'm going to point out what I'm looking for. And the first thing I'm looking for the differential. So I'm going to say I see the 2, I see the x, and I see the dx. So 2x dx. What's that equal to? Du. I'm going to write that down now. All right? What else do I see? I see a lower limit where x is equal to 0. Well, if x is 0, what would you get for u? You just get 1. Okay. If x is 2, what would you get? Again, we're looking at this. You get 4 plus 1, which is 5. Now what are you left off with? You're left off with pi. You're left off with this too, which is going to be 1 over the square root of u, so u to the 1/2. All right? This integration now has become much easier for me to deal with. Let me continue to write it again. So 1 to 5. I'm going to pull the pi out. That's going to be u to the minus 1/2 du. What I'm going to do now, integrate u, add 1 to the exponent, 1/2. You're going to divide by 1/2 or multiply by its reciprocal, which is 2. Evaluate from 1 to 5. What do you get? 2 pi root 5 minus root 1. Well, that looks pretty easy. What do you get? 2 pi root 5 minus 1. If you want, you can expand that. It really doesn't add much to the problem. But again, mistakes happen. So what do we encourage you to do? Please look at the key. All right, what are you looking at the key? You're looking for an answer. What answer you're looking for? This answer. If it's there, great. If it's not, something horribly wrong. We're not looking for close either, by the way. It's got the same answer. I'd also recommend you look over the work. The work is typed up. It's typed up for a reason. We want you to have good access to certainly legible work, not chicken scratch someone's blackboard or on a whiteboard, but typed up. And you should learn to do that as well. Thank you.